Bismillahirrahmanirrahim. Assalamu alaikum. In the last session, we started chapter 8 of D2, and it is about congruence and similarity. We discussed congruence, and in that session, we discussed how we declare that the two figures are congruent. If the angles are same, if all the sides are same, we say these figures are congruent, right? Now let's talk about similarity. In case of similarity, angles of the figures which we are comparing will be the same. All the angles will be the same. But all the sides will not be the same. But ratios of the corresponding sides will be equal. So for the similarity, what are we going to look for? Angles and the ratios. So let's take first example and see how we declare the two figures to be similar. Okay. Okay. We have here two triangles, DEF and STU. Okay. So we have to check whether both the triangles are similar or not. Okay. We don't have any angles here, so in this case, we are not going to discuss about angles, just going to check the ratios. So since for the ratios, we are going to compare the side. So for that matter, it is best to see which vertex is corresponding to which vertex. Okay. Now, for this two figures, if you feel, you can just rotate it. Anti-clockwise, if you rotate it, you're going to have the figure in the same direction, and then it will be easier for you to solve. So, but I'm going to deal it as it is. The first thing is, this is the smaller side. Okay, this is the smaller side. Okay, if I tilt it like this, so what's going to happen? So E is corresponding with T. Okay, so if E is corresponding with T, so F is corresponding with U, and the left, we have left with one vertex, so D is corresponding with S. Okay. Now let's compare the sides and let's get the ratios. First ratio, EF. So for the EF, which side? T, U. So it is 8/7. It is the first ratio. Okay, the second, F, D, or I can say it like DF is equal to S, U, and it is 24/21, which is again 8/7. And then finally, we have here DE over ST. Okay, and we have here 16/14, which is 8/7. So all the ratios are same, so we can easily say that both the triangles are similar, right? Pretty simple. So let's take another example, and we'll see if the given figures are already similar and we have to find the unknown, what do we have to do? Okay, we have these two triangles, ABC and PQR, and the given condition is triangle ABC and triangle PQR are similar. So we have to find the unknowns, this unknown side and this unknown angle. So how are we going to find out? For this unknown side, we're going to compare the ratios, because we compare the ratios of the sides. Okay, so for to compare the ratios, first thing is, let's see which vertex is corresponding with which vertex. So we have angle on this A and we have angle on this P. So A is corresponding with P And similarly, if A is corresponding with P, so C is corresponding with Q, and we are left with B, which corresponds with R. Okay. Now I am going to compare this side AC with A's. For A is corresponding to P and C is corresponding to Q. Okay. If I compare AC with PQ, I'm going to get a ratio. And I know that if the triangles are similar, all the ratios are equal. So, if ratios of these two sides is whatever it is, let it is 6/4, then the ratio of the other two sides is also has to be 6/4. So, I'm going to say that equal to ratio of another two sides. So which will be, I'm going to take this because I am interested in this side. So BC, for B it is R, and Q, C it is Q. Okay. Sorry. So AC or PQ or BC or R. So it is 6/4 is equal to Y over 2.8. So cross multiply, and we have here 6 into 2.8 divided by 4 is equal to Y, and it is actually ones are, and it is 0.7, so Y is equal to 4.2 cm. Okay, so we have our unknown side. For the unknown angle, we can see here that the angle, we have to find angle QPR, and this corresponds to this. Q is C, okay, angle C, and then P is A, and R is B, CAB. Okay, what is that? CAB. It is 30 degree. So X degree is equal to 30 degrees. Because we have done it like this because the given condition was the two triangles are similar. So we compared the ratios and found the unknown side and compared the two angles, and the unknown angle is known now. So let's take another example for the unknowns. Okay. Okay, now again I have two triangles. One triangle is RXS and another is X, Y and Z, and both are similar. Okay, so I have to find the unknowns, unknown side, this portion of the side and this angle. Okay, so let's find out the unknown side first. Okay, now in this case it is very easy that one vertex X is common in both the triangles. So X is in the R axis and X is in XYZ. So it is in both the triangles. Okay, and only thing is R is corresponding with Y and S is corresponding with Z. It is pretty simple. Now, comparing, one is a big triangle and one is smaller. So, comparing the side of the bigger triangle, which is RX, with the side, corresponding side of a smaller triangle, which is YX. So, X is common in both. And comparing with another ratio. So I have here SX and comparing it with ZX. Okay. Now, what is it? So it is basically equal to RX. This is 6 plus 4 is 10 over YX, which is 4, is equal to SX. What is it? 5 plus B. And ZX is 5. Okay. Now cross multiply. So 10 into 5 over 4 is equal to 5 plus b, and it is 50 over 4 is equal to 5 plus b, which is 25 over 2 minus 5 is equal to b, and b is equal to 15 over 2, and which is 7.5 cm. So the unknown side is 7.5 cm. Now for the angle RSX, we have to find the angle RSX, which is YZ, angle Y, Z and X, which is 30 degree. So A degree is equal to 30 degree. So pretty easy, right? Now so we have the idea. For the similar figures, we have to compare the ratios. If the ratios are equal and the angles are equal, the figures are similar. Pretty easy. Okay, thank you very much for now.